unless there is clear.
What is let's start with the alternative hypothesis. Who has thoughts
And
on
this
what
is
that's
where
going to be?
this is our evidence. Well,
Yep.
I was throwing up.
that the null is mu is equal to 0.1.
Okay. So the null hypothesis was that, do you mean mu or do you mean the proportion of
Well,
potatoes?
yeah, the proportion.
Yeah, so that's one difference between these chapters and what we've done before is before we were only concerned with population means, now we're concerned with population proportions. So all our hypotheses are going to be about p instead of mu for this chapter. And so you were saying the null hypothesis so that p is equal to 0.1. What about the alternative hypothesis? What's that going to be? Someone else have an answer for it?
Greater than 0.1, because it's greater than 1.1 that you rejected.
So alternative hypothesis that p is greater than 0.1. And you said that's because if it's greater than 0.1, we'll reject the shipment. I would be a little careful here. The wording is definitely kind of tricky because we're rejecting the shipment of potatoes if this proportion is too small. We're not rejecting, well, yeah, this rejection refers to that shipment. So when we're considering the alternative hypothesis, remember this alternative hypothesis is always, what we want to prove.
So we're the company, we're looking at this from the perspective of the company shipping the potatoes rather than the inspector.
Yeah, I mean, right, the problem is, the inspector wants to prove that there is a proportion of less than 0.1. So that's what we want to prove here, is that this proportion is less than 0.1. And so the alternative hypothesis is actually that this population proportion is less than 0.1. You'll see how that works. So alternative hypothesis is always what you are trying to prove. And a null hypothesis, it's always that this proportion is just some value. So it's the value that we don't want this to be bigger than, basically. Okay, question?
So it's not saying that, because I thought the question was saying that unless it's like less than that number, then they'll reject it. So like your HO wouldn't be less than?
So we're trying to find evidence for this proportion being less than 0.1. So the thing we're trying to find evidence for is our HA always. And yeah, it's a little, it's worded sort of on purpose a little confusingly because, we're saying she will reject the shipment if this proportion is too high, not that she'll reject the null hypothesis. So she will accept the shipment if she rejects the null hypothesis, basically. So this thing that we're trying to find evidence for is the alternative, not the null. Other questions? Okay. Okay, now part B. Does the inspector reject the null hypothesis at a significance level of 3%? So how do we state this question in terms of p-values? What is part B saying? Or what's it asking, I guess, about p-values? So what's the definition of a significance level? It's that alpha that we had before.
How how extreme or how probable the results of our data are if HO is true?
So that's actually the p-value. The p-value is how likely are the results that we got. That's related to the significance level. So the significance level is this arbitrary cutoff, right? Where we're saying this is, if we get results that are less than 3% likely to happen, then we don't think that's just random chance that they happen. It's not just that we got unlucky, that we chose the wrong 200 potatoes for our sample. So the significance level is the cutoff, and if p is less than the significance level, then you reject the null hypothesis. Okay, so significance level is known by alpha usually. And this is some arbitrary cutoff. Where we reject the null hypothesis if the p-value is less than alpha. Okay? So this question part B is asking basically, it's asking if we reject the null hypothesis at a significance level of 3%. That's going to happen if our p-value is less than 3%. Okay, so this is just about finding the p-value and answering the question, is it less than 3% or not? Okay, question?
So, this has been confusing for me, I guess. The significance level is pertaining to the p-value, not the confidence level. So if you have a 97% confidence level, it's not, your alpha isn't 3% unless it's two-sided, right?
So we're not computing confidence intervals right now.
Or levels. So like the 95%.
Yeah, I mean, sort of secretly, when we compute a two-sided hypothesis test, we compute a two-sided p-value. It's the same thing mathematically as computing a confidence interval, but it's not really what's going on here, and so confidence levels aren't really coming up here. But yeah, there is a relationship between alpha and confidence levels. Okay, well let's go through part B then. So how do we find this p-value? Remember, we have this normal approximation for our sampling distribution. And well, assuming the null hypothesis, which is that the population proportion is 0.1, that tells us that the mean of the sampling distribution is also 0.1. Right? This is by the null hypothesis. Okay? And so we have this sampling distribution, but then we got some data, right? We sampled 200 potatoes and 12 of them were defective. So now we have to ask, where does our sample proportion land on this distribution? Okay? So that means first you have to compute p hat. So p hat is going to be that 12 over 200. So this is 0.06.
So sample over population.
Yeah, this p hat is, well, Who can tell me the formula for p hat? Yep.
Isn't it the number of successes over the sample size?
Yeah, it's the number of successes over the sample size. Sorry, it's a little cramped here, but it's the rate of success in your sample. It's a thing that we use to estimate the population parameter p.